projects. In this video, we are going to explain about the project, which is incorporating meteorological data and pesticide information to forecast crop yields using machine learning. So before getting into the execution, first let's understand what is the project about. So you all know that how farming depends a lot on the weather, right? Especially in rainfed systems. So these are the farms that don't use irrigation. They rely completely on the rainfall. Actually, about 80% of the world's cropland works in this way only. That means they depend mostly on the rainfall rather than irrigation. Now think about a place like India, where many farmers they wait for the monsoon season to plant their crops like rice and wheat. If rain arrives late or less than expected, it can mess up with the whole crop cycle. On top of that, climate change. So, on top of the climate change, it makes things worse. One year there might be too much rain causing floods, and the next year there could be a drought. So, farmers they not only lose their crops, but they also lose their income. And it is a serious issue, especially in developing countries where a bad farming can lead to food shortages and increase poverty levels. So predicting this crop yields, that is predicting how much crop will yield is tricky because weather can be so unpredictable and different crops respond differently to it. For example, a heat wave might hurt a wheat crop but not affect the millet as much. And traditional methods like statistical models, so we had some statistical models, there were traditional methods. So these traditional methods take a lot of time to process and struggle to fully capture how factors like rain, temperature, and growth strategies stages interact. And with the climate change in the picture, things have become even more unpredictable. Rain doesn't always come when expected, and sudden temperature shifts are more common. All this makes it harder for farmers to rely on past patterns, which can lead to unexpected drops in the crop yields. So to overcome all these issues, in this project, we are using machine learning based methods. So here we are building some machine learning models to predict the yields of six different types of crops. One is rice, wheat, potatoes, soya beans, sweet potatoes, sorghum. So by analyzing weather data along with the other crucial factors like pesticide usage and the historical crop yields. So the goal of this project is to create a decision support tool that indicates this data to provide accurate crop yields, that is accurate yield predictions. So we are using advanced algorithms like gradient boosting in nearest neighbor because they can pick up on complex patterns that the traditional method might miss. So to make sure that predictions are accurate as possible, we fine tune the models through hyperparameter tuning. So we fine tune these models using hyperparameter tuning methods. So these models will be fine tuned through the hyperparameter tuning and cross validation. This tool will not only help farmers plan better but also give the decision makers reliable insights to improve agricultural productivity and address food security challenges. Moving on to improve the accuracy as the part of the project. So to improve the accuracy in this project, we are incorporating ensemble based methods. So here we are implementing ensemble based methods as the extension, which combines predictions from multiple models to achieve more robust and accurate final result. So here we are incorporating voting regressor in this project, which combines multiple models. So here we have explored additional ensemble technique, that is voting regressor, to further enhance our model's performance. Furthermore, we have developed front end using Flash framework. So we have developed the front end using Flash framework, which enables user testing and incorporating user authentication for secure access. This comprehensive approach not only improves the reliability of our predictions but also makes the system more user friendly and secure for those who rely on it. Moving on to implement this project, we have followed some steps. So first we have imported the required packages and then we have loaded the dataset, that is crop yield data. After loading the crop yield data, then we have explored the dataset to look at the crop yield data to understand its structure and what kind of information it contains. So this helps us to get a sense of what we are looking with. Then we have processed the data. So once we are familiar with the data, we can move on to the data processing. Here we clean the dataset by removing duplicate entries and perform drop cleaning to ensure the data is accurate and ready for analysis. Then we visualize the data. So here We create visualizations like widgets based on area and items, and also generate a correlation matrix to see how different variables relate to each other. Then we selected features. That means we have selected important features based on insights from the all features, concentrating on the most relevant features that affect the crop yields. Then we have label encoded the data. That means we have converted categorical variables into numerical format. Then we have appended all the features to X variable and the target column to Y variable. And then we have splitted the data into train and test sets. Train set is for training the models and test set is for evaluating the models. After we split them into train and test, then we prepared the data. With the prepared data, we started building the models. So with the prepared data, we started building the models for predicting crop yields using the training data. So here we experiment with various machine learning algorithms to see which works the best. And then once the models are built, we focus on training them, evolving, adjusting the model parameters, and optimizing them for better performance based on the training data. Then we compare all the models built using these metrics, which is R square, MSC, RMSE, and MAE. So these are error metrics to evaluate all the regression models. Then we compare them using the graphs. After then, we have developed front end using Flask framework. So we have used Flask framework to develop the front end. Here we create a user-friendly interface to complete with the registration and login features supported by SQLite database. And in the front end, users will utilize the dataset, allowing users to input feature values relevant to crop yield prediction. So the users, they will be giving the input values in the front end. And then those input values will be pre-processed at the back end, and train model will be fit to that pre-processed dataset to give the predictions. Then the predictions will be displayed in the final page of the project. So moving on to algorithms used. So here we have used different models. So here we have built linear regression with different parameter tuning methods. So we have used, we built linear regression with the cross validation. We also built linear regression with the k-fold cross validation, and we also have hypertune using grid search CV. Similarly, KNN also we have done, and gradient boosting. And this is all about the proposed thing. And here we have the extension model voting regressor, which is combined with the bagging regressor with random forest regressor and decision tree. So this model, it has performed well. It has achieved the highest R square value. So we have used that in the front end to detect, to predict the crop yield. This is all about the theoretical concept. To implement, we need basic requirements. So we need hardware requirements and software requirements. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, and JavaScript. So now let's execute. To execute, we need to open the code folder which contains source code files. So let's open code folder of the project. So these are the source code files in the code folder of the project. Let's understand each of them. How will they be used in the data in the project? So in the first folder, we have the data sets. So these are the data sets that are used in the project. So all these columns are there in the main yield underscore df file. So these are the selected important features from the data set. So these are the features from the data set. It is the process data set. So now let's close this. This data set will be used to train the models. And coming to the static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files. The next folder we have is the templates folder. So this templates folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc. And it represents different pages of the website. The next we have is app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have the model file which contain the algorithm information, and this will be loaded into the project code during runtime of the project. The next we have is notebook file. It is a Jupyter notebook file. It contains combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And next we have is the signup.db file. This file is a database file which is used to store the user information. And this is the sample file in which we have test cases using which will be predicting the crop yield in the front end. So let's open it. So these are the test cases. We'll be using them to predict the crop yield. So let's minimize it. So now let's execute the project. To execute, we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. Using the command cd followed by the space, we need to paste the copied path and now click on enter. So here if you observe, current directory is changed to the code folder's path. Now we have to compile the app.py file. So give the command python space app.py and now click on enter. So this command, it will execute the Python script and check for the syntax errors and runtime check. After running app.py file, Flash Framework will host the application at the local address, that is the default address, which is the local host and the port. So this is the local host and this is the port where our application has been hosted. Now we have to copy this local link provided by the Flash Framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here at the end, click on enter. So this is the web page of the project which is displayed in the browser. And this is developed using Flask framework. So now let's click on sign up first and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. So click on sign in. And here we are supposed to provide our username and the password. So I'm giving my username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page. So we can see all these parameters which are need to be given as the input to predict the crop. So first let's understand the parameters. The first parameter which we have is area. This refers to the size of the land in hectares or acres where the crop is being cultivated, which can significantly affect the yield outcomes. The next one we have is item. This specifies the type of crop being grown, such as rice, wheat, or soybeans, etc. Different crops they have varying yields, potentials, and requirements. Coming to year, so this denotes a specific year for which the yield prediction is being made, reflecting the impact of seasonal and year climate variations on the crop yield. That is yearly climatic variations on the crop yield. The next one we have is average rainfall in per year. So this indicates that the total amount of rainfall received in millimeters during the year, as adequate rainfall is crucial for optimal crop growth and yield. So coming to the next one we have is pesticide tons. So this specifies the quantity of pesticides used in tons during the cultivation of the crop, as pesticide application can influence both the yield and also the crop health. The last one we have is average temperature. This represents the mean temperature during the growing season, as temperature plays a pivotal role in plant development and overall crop productivity. So this is all about the parameters to be known. So let's give inputs to these parameters to predict the crop yield. So we have those test cases in the sample file. So we'll be using all these test cases to give as the input to these parameters. So let's use the first test case. So here the area would be 85 hectares. Here we have to give the item. Item number is 4. Here is 2008. The next one we have is average rainfall in millimeter per year. That is 636. Pesticides and tons is 40719. The next one we have is average temperature 7.21. Now click on predict. So here we got the prediction that crop yield is 47517 kgs per year. So it is 47517 per hectare. Let's let's use some more test cases and predict the crop yield. So click on prediction again. So let's try with the second test case. So it would be 56 hectares. Item would be number 8. Here we have to give the year. Next, average rainfall, that is 5113. Pesticides in tons, that is 152.01. Next, we have to give us average temperature, that is 19.71. Now click on predict. So here, based on the information provided, that means based on the given input, crop yield would be 46,670 kgs per
hectare. So now let's give some more test cases. So click on prediction. So let's use this 8th test case. Here we have to give the area. So here area would be 14 acres. Fourth item 1999. Average rainfall is 1761. Pesticides is 127585. Average temperature is 25.88. Click on predict. Here we got the prediction is 28,261,000 for all the area provided. So let's give some more test cases. Click on prediction. Let's try with this 5th test case. So the area would be 14. Item is 6th item, 2001 year. Average rainfall is 1761. Pesticides in tons is 151,523, 26.08. Now click on predict. So for the given year, crop yield would be 26,460 kgs. Let's give some more test cases. Click on prediction. Let's use this 26 test case where area would be 57 hectares. Item number 8. Year would be 2004. Average rainfall is 1181 millimeter per year. Pesticides is 48.28. Average temperature is 20.44. Click on predict. So here we got the prediction that crop yield would be 40,439 kgs per that year. So now let's see the graphs of the project. So click on graph. So here first graph we have is the heat map. Here on x-axis we have the variables and on y-axis we have the variables. This shows the correlation between the variables. So coming to this is the R2 score, which is the metric to evaluate the regression models. So here on x-axis we have R2 score and on y-axis we have the algorithms names used. Algorithms which are used in the project. If you observe, voting classifier, which is the extension, is having the highest R2 score. And this is the MSC graph. Here on x-axis we have MSC value and on y-axis we have the algorithm names. So if we observe, voting is having the least error rate. So it is having the least error. And linear regression is having the highest error. If we have least error in the regression, it means that the model is performing well. And here we have the RMSE error. That means root mean squared error. Here on x-axis we have the values, RMSE value. Here on y-axis we have the algorithm names. If you observe in this graph also, voting classifier is having the least RMSE error. That means it is having the lowest error rate among all the models built. Similarly, this is MAE, which is mean absolute error. So here on x-axis we have MAE and on y-axis we have algorithm names. And here also voting classifier is having almost the least error rate. So now click on sign out. In this way, by using the machine learning models with the hyperparameter tuned methods, we will be able to accurately predict the crop yields. So this would be helpful for the farmers, decision makers, and etc.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.